Hi, my name is Clayton Lawrence, and I'm participating in Challenge 2014. The math problem I'm working today is from Math 1000. It's problem number 8, and it is a related rates problem. So what is a related rates problem? Related rates just means that the rate in one thing will affect the rate of another. In the case of our spherical balloon, represented by v equals 4/3 pi r cubed, the rate of change in the radius will affect the rate of change in volume, because volume is dependent on radius. That just means that the rate of change in r is related to the rate of change in volume. Get it? Alright, so in this problem, we are asked to find the rate of change in our radius, dr over dt, at the point r equals 18 inches. So when the radius of the balloon is at 18 inches, how fast is the radius changing? The problem also gives us the current rate of change in volume, dv over dt equals 25 cubic inches per second. Now, you may notice that we're looking for the change in r with respect to the change in time, but in our volume equation, there's no unit for time. There's no t variable. So what does this mean? This means that we need to find a new way to get to this t variable. So how do we do that? Well, we can use our handy dandy friend, the chain rule. The chain rule lets us use a chain of differentiation that says, in this case, it pretty much just means that volume can be derived with respect to the radius, and radius can be derived with respect to time. That means that if we're looking for the change in volume with respect to time, we can multiply the change in volume with respect to the radius by the change in radius with respect to time. If you look at it algebraically, the two r differentials right here, they actually cancel out and would leave you with dv over dt, which is what we're looking for. So to start the problem, we can we pretty much use this setup to begin. So dv over dt equals the derivative of our volume equation with respect to r. So dv over dt equals the derivative of this 4/3 pi times 3r squared, because when you take the derivative of 4/3 pi r cubed, you bring this exponent down in front of the r and then subtract 1 from the exponent. So you bring 3 down, and then you do 3 minus 1, which is 2, and 2 becomes the new exponent for r. So after doing the derivative of v with respect to r, you multiply that by dr over dt, like I have right here. So now we can move on to the next step. The problem told us that dv over dt, our change in volume, is 25 cubic inches per second. This means that we can go ahead and plug this rate of change in volume, actually, the rate of change in volume in for dv over dt. So 25 can just drop kick 25 in for dv over dt, and then simplify some of this algebra. So what I did was canceled out the 3's, because 3 in the numerator and the 3 in the denominator cancel out as 1. So we're left with 25 equals 4 pi times r squared times dr over dt. Now, the problem told us that we're looking for our rate of change in time, dr over dt, a rate of change in radius, actually, dr over dt, when r is at 18 inches. So we can actually go ahead and plug this 18 inches in for r, because that's our instantaneous radius. So 25 equals 4 pi times r, 18, squared times dr over dt. Now all we have to do now is isolate our dr over dt by doing some simple division. So we divide both sides by 4 pi times 18 squared. 4 pi 18 squared. And this side of the equal sign will cancel out as 1 because you're dividing a number by itself. And we're left with dr over dt equaling 25 over 4 pi times 18 squared. So that means that our final answer is the rate of change. Our rate of change in radius is 25 over 4 pi times 18 squared, which is approximately 0.0061 inches. Approximately 0.0061 inches per second. So at 18 inches for this balloon, the radius is changing at a really slow rate, but it's changing at 0.0061 inches per second. That's all I have for you. Can't wait to meet you all.